We would like to welcome you to the Concrete Testing 101 for Quality Control Managers. One of our presenters today is going to be Renee. She is 51% owner of Beckridge Construction. Renee has a mechanical engineering degree from CSU, which is Colorado State University, Fort Collins, Colorado. Renee has worked as a senior mechanical engineer at Thiokol Propulsion, working on federal projects and for NASA and the space program, along with several Intel facilities across the U.S. before getting into general contracting. Renee has been doing quality control in federal building for 20 plus years.
Our other presenter for today is Greg, and Greg came up through the ranks of the Sheet Metal Union. He was a certified test and balance supervisor, a building systems commissioning agent, and a fellow small business owner before he came over to quality control in federal contracting. Greg has been doing federal construction for 30 plus years. We're really excited to have you QC managers with us today to go through some Concrete 101. We're going to be hitting on 4 main topics today. We're going to be talking through preparatory meeting do's and don'ts. We're going to be talking about prep for the pour day, so what we do before pour. We're going to talk about the steps when the trucks roll on pour day. And then our last bullet, we're going to go through some test result collectings and what ifs. If the test results don't necessarily come back like we want them to.
Prep meeting do's and don'ts. We're just going to dive right on into this. First bullet here, make sure the testing agency is present for the preparatory. This is so extremely important because they are the testing agency that's going to be looking at your mud. They might weigh in on testing, specific testing requirements, as well as their do's and don'ts. If you are on a Corps of Engineers project, it shows a lot of good faith to your QA and to your Corps PM that you are involving your testing agency from the very beginning. Be sure to outline any variances submitted and approved via RFI or submittal concerning the pour so the QA has it fresh in their mind. A lot of times the concrete mixes might be refined through RFI or variant submittals. Sometimes you might not have that QA or that PM that has reviewed your submittal and approved it. You might have another one out there that is not familiar during the pour with what is actually being poured. Be sure to discuss pumping versus tailgating. Control of the pump truck, testing and initial pump dump, etc. If you've got the ability to have your pump company there at the preparatory, that's great. A lot of times that won't happen, and obviously your concrete plant operator will not be there. I've never seen that happen. Oh, how nice that would be, but that never happens. Our next bullet is water, water, water. Concrete subcontractors, water is their friend. QC managers, especially on Corps of Engineers project, water is the devil. Water is extremely bad on a project. You will need to discuss the spec and what it allows and does not allow. No one can allow the addition of water but the QC or the QA. It's all about liability. It's all about the dollars. Ultimately, in the end, it's up to the QA to approve, and then you as the QC to allow it or not allow it to happen. A lot of times these decisions might go to the PMs, but ultimately it resides with you, quality control managers.
Yeah, you need to find your voice, QCs. Controlling the pour and the mud and how it gets poured and it's treated on this day, this is your show. You need to drive it though. And if you take a weaker stance and you don't find your voice, you are going to have others around you make those decisions, and they may or may not be per spec. Pump trucks typically love to side with the subcontractors, and they know the drivers of the trucks typically, right? And so I've seen them on the slide try to add water and okay the addition of water, and we've had to get on them. So this is a pretty important topic.
That's right. And again, don't forget, you're in a prep meeting. You don't want a subcontractor in your prep meeting telling you that they're going to add water because they want to. It's their mud. It's not their mud. It's the end user's mud. It's the client's mud. As Renee just said, you will receive a lot of pressure from the sub to add water, and because concrete is a whole heck of a lot easier to work when it's wet. It is not okay to add water. You're going to see this throughout this presentation, that it is not okay to add water. Now, there are certain exceptions. You might have some QAs that are in your prep meetings. Some batch plants, when they submit their batch tickets to the drivers and you get them in the field, they might have handwritten on there how much water can be added before the mix design just starts breaking down and does not come to the expected compressive strength and characteristics on performance. You might talk about that in your preparatory, but again, it is ultimately up to the QA, and the decision shall be set forth in your preparatory.
Absolutely.
You want to discuss hot or cold weather placement plans if the season requires it. Cold weather is a big one. Extreme hot weather is a big one. You need to have a plan of action, and probably it is a submittal item in your register what those two hot and or cold weather plans will be and how you are going to adhere to it. You also want to discuss where the field samples are to be taken from the truck versus pump and the ACI ruling on that. At Beckrich, as a rule of thumb, corporate policy, we always take our samples at the point of placement. That is very, very key and crucial to where you're going to be doing these samples at.
Absolutely. So going on, you also need to talk about the cure method, what's been approved to be used. Cure compounds, if you're going to use them, if they've been submitted and approved, burlap versus wet, the application, and the color of the approved cure. That actually came up on one of my projects a few years ago. Cure was approved through the system, and it came in a different color than the base was used to seeing. So as soon as they started throwing it down, it was stop, 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 and a lot of panic until we proved that that was exactly what had been submitted and approved. So save yourself that headache when you're in the prep meeting and talk through that. Discussion of timing of saw cuts needs to be talked about, and this is near and dear to most QC's hearts. It needs to be done the same day within the time frame, even if everyone has to stay late to do so. Have always had a lot of pours run late in the day after normal work hours, and no one wants to stick around. No one wants to cut it. Well, we'll be back first thing in the morning and it'll be fine. It just never cuts the same. So you need to talk about that at a prep, because if the supers need to get lights out there, whatever you need to do, if you don't plan on the mud showing up until late afternoon, you're going to lose the sun. You really need to talk about that and make sure that your subcontractor who's doing those saw cuts are on board. You also should talk about the depth of the saw cuts and how important that it is correct. And QCs, you need to be there with calipers or whatever means you're going to be using. You really do need to verify the depth of those cuts when they start. Going back over cuts, never works. Saws jump, it just makes a mess out of slabs. So please make sure that you're there on site and you are verifying the depth of those cuts. Next, you need to talk about protection. You need to discuss who's going to be protecting. I've actually set in on preps where it's a big aha moment either for the subcontractor or the superintendent, because they find out at a prep that they're in charge of the protection and that's under their contract, or it's not under a subcontract, and the supers have to self-perform the protection, because that means making sure that the superintendents have enough labor and blankets or however your means for protection is, and that they are on site ready to go the day of the pour. So make sure that that's part of your agenda. And then the supers need to talk about the placement plan. So it's much easier during a prep day to throw a site map down and have the supers discuss where the trucks are going to come in, where the cleanout's located, and the order of placement. So they need to go through that. It shows your end user that everything's thought out. It ensures that our superintendents have actually thought that out, and we're not playing crazy circus with the trucks on pour day, maneuvering them around to get to certain areas. So make sure you talk through your placement plan as well.
Now we're going to be talking about preparing for the pour day. Very first and most important bullet that you have here is make sure that you have your testing agency on board and scheduled. Last minute pours will not happen and cannot happen without your testing agency there. Most testing agencies require a minimum of 24 to 48 hours notice. Make sure you get those scheduled. Next one, you want to make sure you have the rebar and form inspections done and inspected with plenty of pictures before the pour. Typically, the way that we run our projects is the day before the concrete pour, we talk to the superintendents or whoever is managing the rebar and the form work. We get that inspection done early the day before. That way, the subcontractor has time to fix any issues. You will get a rebar and form inspection report. You want to make sure that those are kept on file, and that is your backup. Make sure you have provided the testing agency with submittals and specifications, and you keep a copy of those in a folder in your trailer. I cannot tell you how many times we get testing agencies that come out to our sites, and their administrative managers in their offices have not given them any idea of what they're testing and what they're testing to. So we always keep that folder on all of our projects. That way you can just take it with you out in the field. This is what you're pouring. This is what it needs to be poured at and the specifications. Check with the superintendent on the number of cores needed due to the schedule. Sometimes we ask for additional cores for an early break due to schedule. This comes down to coordination with your superintendent and your contract with your testing agency. Cylinders and cores take money. They cost money. If your superintendent is looking for an early break so they can tear down the formwork and they can start setting materials or do whatever they need to, you might want a 3-day core along with your contractual breaks that are required by spec. Here at Beckridge, we always request that we get one additional cylinder to be held in reserve if for some reason we get low breaks. So please keep that in mind. Make a copy of spec testing and the mix ID to keep on you in your pocket on pour day. Air content, slump, weight, compressive strength, mix ID number. It's very easy and handy just to have a little spiral notebook in your pocket, in your safety vest, that just has that little bit of information written down instead of you having to carry that whole entire book around with you. Less paper, your hands are freer, it just works out extremely well. Watch the weather forecast and know your temperature limits and approved cold weather plan. If you're in the middle of summer, your temperature is probably not going to be an issue unless you start getting up into the super temperatures, super high temps, and your super low temps. You want to know what your conditions are. You might have to take the temperature of your substrate, of the ground, of where you're going to be putting the mud. Check your temperature gun for batteries and make sure it is in working order. It is very wise and very smart QCs. Keep your pocket thermometers. If you've got a little laser temperature gun, make sure it works. That way you can double check what the tester is looking at and what you need to ensure that the pour can actually take place. Be sure testing agency has the cure box set up on site. Which leads us into the next bullet, lab cures versus field cures. Be sure you know what is required by spec. With your cure box, you want to have the cure box there before the pour takes place. You want your cure box close to the pour so it's next to the conditions that you're pouring in. If it needs to be heated to represent the blanketed condition, if they're out in the open, if it's nice weather, summer weather outside, and how long it has to be in the field.
Yeah, very seldom does pour day go perfect.
That's
There's
right.
almost always a hiccup on pour day. So if you follow this checklist of what we see for our prep when we get ready for the trucks to roll, it's going to really help you, and it will eliminate an awful lot of the hiccups that are typical.
That's right.
So now going through the steps when the trucks actually roll on pour day. So you need to make sure the pump truck operator understands that you will be monitoring the mix and that the only people allowed to add water are the QC and the QA. And I understand that we've kind of gone over that, but we just can't stress it enough. I just can't stress enough. Again, QCs, this is your show. You have to have a voice on pour day. You need to make sure the testing agency is there and set up. Do not start to pour or pump until the testing agency is there. If you dump too much and you haven't tested, then you've bought that entire truck no matter what the tests show.
That's exactly right. And sometimes trucks are late. Sometimes pours get postponed by an hour or two due to one reason or another. You have to immediately communicate with your testing agency. Sometimes these testers are extremely busy. They have only accounted or allotted that they're going to be there on your job site for 30 or 40 minutes. If you're running 2 or 3 hours late, you need to communicate that with the testing agency. Sometimes they will pull your tester and cannot show up until the next day. If that's the case, your pour is now moved to when your testing agency can be there.
Yeah, it has to be there. You need to ensure that the testing tech for your testing agency understands your mix, spec, and number of cylinders to be collected. So I understand we've tried really hard and you've got your testing agency in on the preparatory. You think everything's home free, but they have turnover, they have issues, they may not have passed down the information. So it's always good to understand or make sure that your tech understands too what is happening that day and what you're actually pouring to. You need to make sure that your concrete subs know that you're going to dump a small amount and then hold for test results. So that's an eyeball to eyeball conversation, toe to toe in the dirt with the foreman for the concrete crew. And he is going to definitely want to be dumping, and he's going to want to be dumping fast because he's got trucks coming right after these roll out. But you need to tell him, hold until the tests are done. It'll just take a minute, and then I can clear you to dump. So be sure and find your voice for that one.
That's right. You definitely have to be vocal with that, just like Renee says. Typically what we do is we dump 3 to 4 yards on the ground. Obviously you want to follow the ACI rules. When we get 3 to 4 yards on the ground, like Renee said, we hold. If you've got bad tests and it's bad mud, it's easier to pull 3 or 4 yards off the ground than it is an entire 10-yard truck.
Yeah.
Keep that in mind.
Because then you buy it, and as the QC for the general contractor, you have bought that for your general contractor. When the trucks do roll up, the first thing you should do is climb on up there and ask the driver for the batch ticket. Get a copy of that batch ticket. The very first thing that you need to do is check the mix ID to make sure it is correct. And I have actually had quality control managers dump almost an entire day worth of mud without checking and have a batch plant accidentally send the wrong mix out. It has happened. It continues to happen. So number one, you climb on up there, you ask for a copy of that ticket, and you check that mix ID. The next thing you really need to do is ask the driver if he added any water. The answer should be no. They will probably be lying to you when they say no. But you need to at least give them the option and the opportunity to lie to you and say no. What you don't want is having them add a bunch of water all the way. When you're talking federal contracting, which is really what the whole training is pertaining to, for federal contracting, we all know different bases are harder to get on, different gates are harder to get through the inspection process. So a lot of times these drivers know that, and they will continue to add that water into those drums as they're getting through there. Hopefully they don't, because that does wreak a lot of havoc, obviously, with our mixes. The very next thing you need to do is check the time on the ticket. Typically, your specifications are going to allow 90 minutes or 300 rotations. If the time is close to the limit, you ask the driver how many rotations he has, and you take a look at that. If you're over on time and rotations, you got to turn that truck away. That is your job. Your job as a quality control manager is to protect your general contractor. You have to protect them from risk. Pouring a truck that is out of spec means that you've bought that no matter if the cylinders are in or out. You just got to turn it away. That's when you find your voice. You're not going to be everybody's friend. Quality control is just not that kind of job. You're not a friend. It's just your job. Pour day is definitely not the day that you make friends on site, but it is an extremely important day to protect the general contractor's interest. And you've got to watch that 90 minutes or 300 rotations. If you've got trucks backed up and you're sitting with one pouring and two in line, and you check the second one in line and it's over on minutes and he's at 260 rotations, there's just no way. There's no human way possible that you're going to dump that truck in front of him before he reaches the limit on rotations. You've got to turn that truck away. As soon as you do turn that truck away, you need to get a hold of superintendent, and either you and or your superintendent needs to let the plant know. Because if there's any way for them to stall, if you have additional trucks coming, you can avoid the cost of additional mud being lost. You need to let them know there must have been a delay, or you didn't stage your trucks right. We're running over. We're having to turn trucks away because they are no longer in spec on time and rotation.
Here are more additional QC steps when trucks roll on pour day. You want to dump that small amount, usually between 3 to 4 yards, and have the testing agency take samples from the point of placement. This is very important, from the point of placement. Follow the tech and witness the tests, and get ready to write the results down. If something doesn't look right when they are testing, ask them why they are doing it that way. If they do it wrong, politely question them. It is good for all QCs to have their ACI Testing Tech Level 1 cert. So you need to watch how they're pulling the cylinders, how they're pulling the samples, how they're doing their air, their slump, their temperature, how they're doing all of that. It's good to ask questions. A lot of testing agency techs will be glad to talk you through the process. And again, if you have your ACI Testing Tech Level 1 cert and you know they are doing something incorrectly, it is your job to speak up and have them answer what your questions with why they're doing it.
You've hired them as the expert, and typically they can do no wrong, usually. However, we have had techs come out and muddle through the tests and do them incorrectly, and we have actually had to ask techs to leave and be replaced on different core jobs because they're not doing it properly. And like Greg talked to Beckridge, all of our quality control managers are ACI certified for their testing tech level 1. It's really a good thing to have if you're a quality control manager, because very seldom are you on a job, vertical or horizontal, where you're not going to have concrete testing. If your general contractor won't pay to send you through that ACI, or that's something you don't have, you can Google the different testing procedures and watch videos of how to properly do it per the ACI, and that will help you as well.
That's right. The theme of this is you want to educate yourself. You want to educate yourself either with getting the ACI certifications or by Googling or finding out that information of what to look for. And don't forget, on Corps of Engineers projects, ladies and gentlemen, you're more than likely going to have the QA there with you watching the tests as well. Right. The QA is going to look to you to ensure that the testing is done correctly. So you definitely want to have a firm grasp of what you're doing. So after all the field tests are done, and the tech is going to ask you where to place the cylinders on site. So we've talked to that. You know, if it's going to be field cure versus lab cure, the conditions, it's going to be stored in the field, by the pour, so on and so forth. So it's very important for them to know that. Now, if you're at the point to where all the field tests have come out correctly, you want to immediately let the truck driver know and the concrete sub know that they are good to proceed with the pour. All of this testing shouldn't take any more than 10 or 15 minutes at the most, so you want to get those guys going back to work, and so you're not losing that mud. If the tests are not okay, you need to reject the truck. Now, these truck drivers are going to say, well, I can add this chemical, I can add this component, I can add this mixture, I can add water. It is not okay to do that on a United States Army Corps of Engineers project. It is just not okay. So obviously you need to reject the truck. The caveat to this is before rejecting the truck, we weigh out if it is out of spec and how critical it is to the pour, i.e., good example here, if it's a typical sidewalk or if it's a 10-inch double mat slab. Typically, we let the PMs know, we use our voice, and we give them the information to let them make the decision.
Yeah, just also depends on how your company is set up. We really never like to see general contractors reporting to a project manager. We like to see them reporting to someone higher and separate from a project manager so they truly have their voice to properly QC. But there are times quality control managers, we get overrode on this.
That's right.
So all we can do is definitely tell them we would reject the truck and hope that you are able to enforce that.
That's right. And as Renee spoke before, if we reject, we need to be sure the batch plant is notified immediately to change future trucks, and they will probably send their QA out to do side-by-side tests. Now, on the side-by-side tests, what we're talking about is all batch plants have an in-house QA. They will send them out to the field if need be or if they're requested, and they will do side-by-sides, the batch plant's QA along with your special inspection tech. They will want to make sure that they're coming up with the same information. Now, 10 times out of 10, that batch plant quality control rep will test out of the tailgate of the truck. They will not go to the point of placement where you have tested. Contractually and specification wise, they are not the approved special inspector. Your special inspection company is. So please make sure that you weigh that out correctly. Coordinate with the testing agency if you need additional testing. A lot of times your spec requirements due to the size of the pour or the type of concrete that you're doing will require multiple tests at different intervals, so you really want to make sure about that. If you've turned trucks away and you need to keep them to keep sampling, you need to make sure that you've communicated with them for any additional testing, because additional testing is not free, it's dollars, and you will have to answer to your PM for that, so you want to make sure you have good factual information. If something goes wrong and too much was poured and test failed, take a cylinder to prove it is okay. So we kind of talked about this. If you've got 10 yards of mud out on the ground and you've tested the last yard out of the truck and it fails, you want to take cylinders of what you have on the ground if you can't get it out, and you want those specifically labeled why and where they were at, so you have that backup information. If the batch plant testing firm is there, be sure the results are close to ours. We just talked about that. They should line up pretty darn closely. If they're pretty far apart and you get very wide range and variance between the special inspector and the QA or QC from the batch plant, you need to figure that out. You need to ferret it out, and why. 2 constants with concrete. Number 1, there is a crack in every truck, ladies and gentlemen. It's just going to happen. It's inevitable. Number 2, there will be hiccups. It is going to happen. Nobody has ever done a concrete pour and it's gone smoothly. You have to be prepared for the unexpected, or at least get yourself as prepared as you can. It is how we react to ensure mud placement meets spec that matters. You want to make sure you're doing the field testing. You want to make sure you're gathering the batch tickets. You want to make sure that the contractor isn't adding water, etc. It's pretty darn important.
It is. And the other thing I noticed that I didn't get on this slide is organization of batch tickets and test results. I know we talked through that in our QC 101 training module, but just know that you need to keep a handle on that. You need to keep copies of all of your batch tickets, and you need them in order. Somehow you need to file that. You need to cross-reference those when you get the tests in, so that you can keep track of that as well. That way it's easier to prove what the batch tickets match up to the tests if there were any issues. And then if you have to enter any of this data into a database such as the Corps of Engineers QCS RMS, you're going to need to number them. So you're going to need to correspond the number in that system to the batch ticket and the test report for that area. So it can be kind of a tricky thing, and like I said, I know we go through it in other training modules, but I did want to briefly mention that here.
That's right. Organization is very important, and you never, ever, ever want to do a pour and not get the batch tickets. You grab the batch ticket from every truck, like we just talked about.
Mm-hmm. So this is probably the section that I get the very most questions on. And normally when I get questions, I have fellow owners of general contracting companies and or PMs calling me saying, oh my gosh, this didn't work out. We've got test results that failed. What do we do now? So before we start going through this slide, I want the QCs to know that typically this is not all in your realm. You can pose different options to your project management or upper management staff, but this is an ownership / project manager type decision when we have tests that fail. Documentation obviously is your #1 job as a quality control manager, but it's pretty important for everybody to understand the what ifs. So going through this slide, you need to make sure that the testing agency has your email address to send results to. And if certain number of days go by and you haven't seen those results, you need to politely ping your testing agency and make sure they haven't been lost in the great abyss called the intranet or the web or wherever they're lost. Somebody's email junk folder. So definitely want to make sure you're getting those test results. When those results come in, it's not like, you know, you get a bill in the mail and you want to put it in the junk drawer for a week because you don't want to face the music. You really need to check them immediately. So when you see those come in, please take a look at them right away. You need to make sure that the reports on the pour are marked correctly for spec values such as air slump, pass, and fail. You know, again, everybody's human. I've had testing agencies that we've worked with for years, and every once in a while they'll send a report and they've quoted another mixed design or another spec on there, and they'll mark it fail when it's really not a fail, and you got to call them and have them redo the report and remind them that, no, that's not really our spec. So take a look at that. And then you need to watch the mixes and how the breaks are coming in. So you can watch that trend. Typical core breaks, they want to reach strength by 28 days. So at 7th day, if something really looks hooey and it's not even coming close, then you probably know 28 is going to be a problem. So definitely keep your eye on that. You need to alert your superintendent, your project manager, and your corporate QC manager, if you have one, of any break trends that appear to be a problem. The sooner everybody knows there may be a problem, then everybody can start brainstorming on different options for a solution. The core also needs to be alerted of low breaks and a recovery plan or options. Now, whether you choose to discuss that with the core or put that in an RFI is up to you and your management team. Typically, before we go to the core with that information, you should have a discussion with your super and your PM and your corporate QC, and the team as a whole comes together with a recovery plan. Just running to a client saying, oh my gosh, this failed, can sometimes be detrimental to the team and the direction you would like it to go with different options. So if you guys come together and talk about that with a recovery plan when you go to them, that usually ends much better in your favor. You need to let the testing agency know if they need to hold off on cylinder breaks to let the mix have more cure time. So, you know, sometimes they've got 2 for 28. If you're a little worried, and then, you know, you've got some for a 90-day break, or 56 and then 90. But if you need to hold an extra one for a later break, be talking to them about that. Also, recovery plans can include a wide range of things. So after the pour cores, sometimes you can go in and core after everything's cured. We have cored slabs before in different locations and retested those. Typically, though, your testing agency is not going to have a hiccup at their certified lab to the point that you're going to get drastic changes with a core that you've taken after the pour. It's costly. You've got to seal it back up, and not sure that you're going to get the results that you're looking for, but that is an option. Sometimes we offer extended warranties. That obviously is a double-edged sword for lots of reasons, mainly because of the last bullet on the last slide that Greg told you. #1 rule, there is a crack in every truck. It just depends on when it's going to come out, and you have a much higher chance of that coming out during your warranty if you have to extend a warranty. Another option for a recovery plan is replacement. As a general contractor, we hardly ever really want to replace an item. But sometimes replacement is a better deal than an extended warranty depending on what it's on. Hard stands are really heavily used in the military. So if it's like a hard stand, you're going to probably get a lot of warranty calls if you extend a warranty.
And as Renee said, when we're talking about recovery plans, quality control managers, you need to rely and have the input of upper management
this
and
isn't your
ownership.
decision.
This is not your decision.
No.
You will probably be asked for input, but this is all about dollars, and dollars are out of your realm.
Yep.
That's corporate QC, project management, ownership, as Renee stated.
Yep. And then you need to attach all the batch tickets and reports to daily reports. Keeping up on the paperwork and staying organized. Briefly talked about that in the last slide. A giant stack of batch tickets is not fun to dig through when problems occur. So if you end up in that what if situation, you're going to want to be able to produce the batch ticket, the test report, all the data from that area of the pour that day. And, the project management team and your corporate QC is going to get the batch plant involved as well. So if obviously mud is out of spec, they've got some culpability in it. Typically these recovery plans are not decisions made in one day. And a lot of times we have like a postmortem, for the lack of a better term, meeting where it's the upper management, the QC, the batch team. Sometimes we bring our testing agency in on those, and everybody talks about how close was it, how out was it, were there problems at pour day, what could have happened, kind to weigh in your options for the recovery plan.
That's right.
Yeah. And then we talked about keeping all the files. So for the whole warranty period, you really need to keep all those files. Back in the day, we would have binders and binders and binders. Now, though, we are in the digital electronic age, so a lot of times we scan all those in. But at whatever your client wishes, whatever your contractor wishes, but be sure you keep all of those for what ifs that come down the road. And then that takes us to the summary of what we've gone through today. So talking towards the top to the bottom, you need to make sure that you discuss all the required items at the preparatory. And we've kind of gone through a slide and listed what we consider to be those items. You need to make sure that testing agency is lined out at the prep as well as on actual pour day. Make sure that they know what they're testing to. Make sure the batch ticket matches the approved mix design. Grab that very first thing when those trucks show up. You need to check the truck's time and revolutions. Make sure that that's in spec. That's number one for turning trucks away. Do not add water unless that's been discussed and approved by your clients. That's a killer. You need to watch the tests and breaks as they come in and alert everybody if you get into our magical what if situation so that recovery plans and items can be addressed sooner than later.
Both Renee and I would like to thank you for taking this training module on QC Concrete 101.
Hello everyone, and thank you for joining us again today. Today I'm going to talk through ACI Concrete Tests. Let's dive in. So in this training, we are going to talk about temperatures, rotations on the trucks, batch tickets. We're going to look at the slump test. We're going to dive into what goes into air and weight tests, and then we're going to talk about cores and strength. So here's the disclaimer. We are not the ACI. We do hold ACI Field Testing Technician Grade 1 certs. Honestly, all my QC managers that we've trained through our house goes and achieves this and gets this certificate. We strongly suggest that all QC managers pursue an ACI class and certifications. However, we are not affiliated with the ACI, nor are we ACI field testing tech instructors. This program, this presentation, has only been developed to give you information on what is being performed. So as a QC manager, you have some familiarity with the required ACI concrete tests. Why is it important to know this information? So I just went through this whole spiel about how we're not ACI techs. If there's a third-party testing agency doing these tests for you, which I'm going to say 99.99% of the time there are, many times there's also side-by-sides done by the batch plant. Why in the world, as QC managers, do we need to know how to perform these? Well, we always hope that your third parties are professional and on their A game every day. But honestly, that is pretty much an unrealistic expectation. More often than not, testing agencies are going to have lots of turnover. They're going to have green testing techs out there. It happens. New employees, everyone's human. Somebody may just have not slept well and is having a rough day and screws up a test. As a QC manager, you have to ensure that all tests are done properly per spec and code. So in order to make sure that the side-by-sides are right, that your testing agency is doing everything right, they're handling the field specimens for your breaks right, all of it, you've got to know how to do it yourself. And that is why we made this training. First test needed to be done by you. Temperature. Get your temperature guns out. Make sure that the batteries are fresh the day before. You don't want to show up to a 4 a.m. pour and be shooting temps with your temp gun and then have to search for batteries in the dark on site. We've been there, done that, got the t-shirt. Check the specs for your minimum subgrade temp and what's allowed for placement. Usually, most government specs, it's 40 degrees and rising. Truck rotations, this is again something that you, the QC manager, checks. No third party does this. You have to ask for the count as soon as the truck arrives. So when those trucks line up on your site, you need to be jumping up and asking for their rotation. Usually most of the government specs have a max rotation of 300. If you're on a site that has really tricky access or it's far away from your batch plant, you're going to really want to pay attention to this, because if they're over on those rotations, you're going to need to send those trucks away depending on what your specification says. Batch ticket, batch ticket, batch ticket. I'm not going to say it again, but I probably will say it again, batch ticket. Please collect those before those trucks dump. You need to check the mix number against your approved submittal. And I just realized that I misspelled submittal on here, so I will fix that. But check that mix number against your approved submittal. It's a must. You don't know how many times we have been called in to clean up messes and the QC didn't check it and they've dumped a mix that didn't match. And it's just bad news. Nobody wants to be busting out a whole truck of concrete because the mix didn't match the spec, or losing money or losing lots of time on a warranty. So please check that. Those are the three number one things that you as a QC manager need to check. Okay, concrete temperature. According to ACI standards, the temperature of concrete at the point of placement should typically be maintained between 50 and 90 degrees F. This range ensures optimal curing and setting of the concrete. So when your third party gets the mud from point of placement, or however your specification is requiring it, typically it's point of placement, they're usually going to put it into a bucket, or they're going to put it into a little wheelbarrow. They should be dumping a thermometer in right away to make sure the temperature meets ACI standards. Slump test. Slump measures the workability of the concrete. Curbs and pavement require a really stiff mix that holds its shape immediately after it's placed, while walls or columns with a lot of reinforcement needs a mix that's going to flow easily around all that rebar and all the steel into tight places. In order for a slump test to be done, you have to have a flat surface plate, a tamping rod. Diameter and length of the rod is important to ACI. You need to have the sample scoop, the slump cone. You need to have a measuring device, tape. You need to have a water sponge to wipe down the cone and the rod. So if your third party's rolling up and they don't have these things, they're already messed up. It's already bad news. All right, continuing on slump. Sampling is very important. A composite sample needs to be done with 2 different samples combined. Location of the sampling needs to be per spec. So again, we mentioned this, but look at your specifications. Typically, it's point of placement. Once the sample is obtained, the clock starts, and all of the slump test has to be done within 5 minutes of sampling. The slump test is done in 2.5 minutes from sampling. So when we say all tests, it's everything we're going to be talking about. It just needs to roll. They need to roll fast, right? And slump has to be done within 2.5 minutes. Remember, collecting, testing, and examining fresh concrete early in the placement operation is a valuable opportunity to intervene if a problem is detected. This is the jargon straight from the ACI. It sounds like it's common sense, but those trucks roll up. They're going to dump, just a little bit. Then your testing agency needs to get in there and stop the placement until the test is done. If the tests fail and you have to send that truck away, you don't want to have dumped more than just a little bit of that truck. Okay, so please make sure your third party is on site before you start dumping your mud. Make sure they're doing these tests. All right, so this is just a really good pictorial view. We're going to watch a video next, but it shows the sampling, it shows the rotting, it shows it being done in 3 steps, screeting it off, pulling that cone up, straight up, and then how they measure the slump off of the top of the cone. Scoop. This is going to be how to do the test. We're going to start with the scoop. The mold is filled in 3 layers of equal volume, not depth. The cone's depth of equal sample volumes works out to about 2 5/8 inches for the first layer, 6 1/8 for the second. When placing concrete in the cone, you move the scoop around the opening to evenly distribute the sample, and the final layer is heaped over the top with more added during rotting if needed. Pro tip, save time and guesswork by marking the outside of the slump cone with the required depths of the first and second layers. Typically, this is done when the guys roll up, they have their cone marked. Is all of this truly important? It absolutely is if you're going to have to test per ACI. When you take the field test tech examination, you have to do these tests in front of the proctor, and you have to do it per all of these steps. So we're not making this up. I know it sounds really silly. I know the fact that you've got to scoop it in a certain way, the amount of rod thing you've got to do, we're going to talk about. By the time you're done with this, you're just going to be like, wow, I had no idea that was all being done when those guys roll up to do my tests. But it's all important per ACI. Okay, consolidate. They're going to use that tamping rod with specified dimensions and shape. It's very critical to test success. Attempting to use a rebar or other items does not have a hemispherical tip, pushes down aggregate particles instead of uniformly consolidating the concrete. Too short rod is difficult to grasp, may prevent the layers from being rotted to the proper depth. You got to consolidate. Consolidate every layer with 25 even distributed strokes throughout its depth. Penetrate the rod layer without striking the base plate or surface. For subsequent layers, allow the rod to penetrate about 1 inch into the layer below so that you are getting it all mixed together. Vertical strokes of the tamping rod must be aligned slightly at first to ensure even consolidation around the perimeter of the bottom layer. Continue spiraling towards the center with even distributed vertical strokes. Yes, they actually count the number of times you rod when you take the test. And really, if you've got a new testing agency, you should probably count for them too and see if they're doing this right. Pro tip, never tap the cone to consolidate the sample in the way you do strength cylinders or beams are molded. If the slump cone is tapped, moved, or disturbed in any way during that test, the sample has to be discarded and the test has to start over with a new sample. So they shouldn't be whacking the cone. All right, strike off. So like we said, you need to put a little bit of extra on top. After the rotting is completed, you use the tamping rod and you strike the concrete off flush with the cone. Horizontal screening motion combined with the rolling action of the rod gives you a clean strike off surface without compacting the sample. The lift is important when you're lifting that cone off while holding the cone down by one of the handles. You use the other handle to clean away the excess concrete from the base of the cone. You remove your foot from the opposite foot tab or release the clamping mechanism. I've never used a clamping mechanism. When I did these tests, I always just used my foot. You keep the cone immobile while switching hands. You repeat the process on the second side with the hand on each side. Carefully lift the cone straight up without twisting. I always wanted to twist. Don't twist. Vertical lift should be completed in 5 plus or minus 2 seconds. They actually count when you take the test. It really does matter per ACI. This is how you have to do it. When the slump cone is removed, the unsupported concrete sample slumps. And that's what you're going to measure. So when you do the measurement, you put the rod on top of the cone, and then you put the tape on top of the concrete up to the rod. After the slump cones removed, the concrete subsides, or in some high slump mixtures collapses. Measurements to the nearest quarter inch of vertical difference between the top of the mold and the displacement center on the top of the specimen determines the slump value. If a portion of the specimen shears away, the test must be disregarded and another test performed using a new sample. I actually had one shear away during my test when I took the test. I had to do it again. So it happens. Compare and report. The acceptable tolerances of the concrete slump are specified in the project specifications or as part of the concrete mix design. Slump test values that deviate from project requirements should be reported to stakeholders immediately and noted in inspection and testing reports. So then they had a chart here showing the different ranges of slump test values and how they might be used. So this is going to be the video of someone actually doing the slump. I'm going to push play so that you can watch it through.
First thing you want to do is make sure that your slump cone is moist both inside and out. You want to perform this test on a flat, smooth, rigid surface, free of any vibration.
Typically, your agency is going to bring out a piece of poly and throw down.
The cone will be held in place. You can stand on the ears or you can use the slump place and lock them into place. We'll fill the cone, 3 equal lifts by volume, rotating the concrete around the mouth of the cone to evenly distribute. I'm going to rod this lift throughout its depth without forcibly striking the bottom. Half of my roddings are going to be at an angle to ensure that I get proper penetration into the corners. The rest will be across the cross section. Second lift. We'll fill the mold to 2/3 by volume. We'll rod this lift throughout its depth, penetrating the lift below by approximately 1 inch. Third and final lift, we'll completely fill the mold. We'll rod this lift throughout its depth, penetrating the lift below by approximately 1 inch. If at any time the concrete falls below the lip of the mold, you'll add a representative portion of concrete back into the mold and begin rodding where you left off. With a rolling, screeding action, you'll strike off the top of the mold. The tamping rod is the only approved method for striking off the mold. Remove any excess concrete. We're going to raise the mold in 5 plus or minus 2 seconds, clearing the concrete slump by 12 inches. You don't want any torsion or side-to-side movement as you raise this mold. We'll invert the cone, measure down to the offset center, and get your reading for your slump.
All right. So obviously that's not our video. This is a video. I left all of the video accolades on there so you can see which site it was on as you were watching it. So we don't own rights to that video. That video is a really good video though, and you can find thousands of them on YouTube if you just are bored, I guess, or need sleeping aid and want to watch one slump test after another. But that is a good representation of how those are done.
First thing.
Okay, so I know I referenced this on the other one, but this is the chart that is the reference for typical slumps. So I know it was broke up there at the video, but I wanted you to actually get to see someone doing it. So this is a really good reference tool for you, though, especially when you're checking the submittals or you're checking design. Slumps, typically 0 to 1 inches is very low. Very dry mixes and slip forms or paving machines with high-powered vibrations use that. Slump, if you're going to have about 1 to 2, it's a lower slump, lower workability. The mix is used for foundations, light reinforcement paving, and hand-operated vibration. A slump 2 to 4, they say degree of workability is medium. Medium is for flat slabs, reinforced concrete, manually placed, heavily reinforced sections with mechanical vibration. That's typically what I see on most specs, is about a 2 to 4 slump. And then 4 to 7 is very high. It's high workability concrete for sections with congested reinforcement. So if you're doing really tall columns or walls, you're probably going to see that. And that may not respond well to vibration. Now we're going to move on to air weight content. Okay, so the primary purpose of entraining air in concrete is to increase its durability when it is exposed to freeze and thaw cycles with water present. So air entraining admixtures for concrete create small, uniform, stable air bubbles from around 0.01 millimeters to 1 millimeters in diameter in the cement mix throughout a concrete mix. Cement matrix throughout the concrete mix. The bubbles become air voids in the hardened concrete, and they create a relief system, kind of like a cushion system, that's going to allow the expansion of water as it freezes without damaging or cracking the concrete. Additional benefits include a decrease in water demand for mixing and curing, an increase in workability, and a reduction in bleeding and segregation. So that's really why you like to have air and what air does in the mix. You, as a QC manager, don't get to pick how much air is in there, or part of the design that's in the specification and your approved mix design. Most non-air entrained concrete contains between 1% and 2% entrapped air, and some admixtures may unintentionally entrain even more air. So again, that's a whole lot of jargon, but just wanted you to understand, like, hey, why do we even want air in there? Why are we testing it? Okay, just as putting air and training admixtures into concrete creates beneficial air bubbles, mixing, transporting, pumping, and handling the mix can take them out. So it's not only is the air content testing essential, but so is testing at the right time and place. Again, there are 3 different methods. There's going to be a pressure method, a volumetric method, and a gravimetric method. For the purpose of a generalized training, we're going to show you the pressure method. I'm going to say 8 out of 10 times when that third party shows up, they're going to show up with an air pot like shown in the top right, and that they are going to be doing the pressure method. The pressure method is not suitable for concrete with low density aggregates where air in the concrete aggregate pores can interfere with the test. Okay, sample preparation. Once the third party gets there, a representative sample of fresh concrete, and start the test within 15 minutes. Base filling. You fill the meter's base with concrete in 3 equal layers, again, rotting every layer 25 times. ACI loves 25. Strike off. You strike off the top of the surface of the concrete flush with the rim of the base. Sealing and filling. You clamp the top of the meter onto the base. You ensure the pressure is a tight seal. You fill the air gap between the concrete and the top of the meter with water. Pressure application, you pump the top of the meter to the specified initial pressure. Stabilization, you're going to tap that back of the gauge to stabilize the needle and allow the pressure to equalize. You depress the air, strike the pot, minimum of 2 times on the sides. Pressure release and reading, you release the pressure and you read the air void content on the dial. I've got a video, I know. Big surprise. All right, so we're going to watch the video. Again, don't own the rights to the video. It's public. It's on YouTube. You can see the reference of the gentleman and his video, but we're going to watch it because this is the pressure method. ACI specifies a tolerance of 1.5% on plus or minus 1.5 on total air content. So let's watch the video.
After completing the strike off and cleaning of the lip of the air pot, want to ensure that the seal on the top of the pot is moist.
Your third party should have a sponge. They should be using water when they do this.
Give it a slight twist to ensure that you don't have any aggregate stuck between the lip and the seal. You're going to lock your clamps down 2 by 2. With both petcocks open, bleeder valve closed, main air valve closed. You're going to insert water through one petcock. While you're inserting the water, you're going to jar the meter to displace any trapped air. Jarring can be left open to some interpretation. This can also be considered jarring.
I've seen it done both ways.
Loosen the constraints of the entrapped air and get it out. After you've got standing water in both petcocks, you want to pump up the air meter to its IP. The IP on this pot is 2. Tap the back of the gauge to stabilize the needle. With the needle stabilized at 2, we're going to ensure that we still have standing water in both petcocks. We'll close both petcocks. Now at this point, we'll depress the main air valve to release the air from the air chamber into the pot. When we depress it, we're going to strike the sides of the air meter. That's a plural word, sides. You need to strike the pot a minimum of 2 times. After striking the pot, tap the back of the gauge until the needle stabilizes. Continue to hold the main air valve open until that needle stabilizes. Once the needle is stabilized, you can release the valve and get your reading to the nearest 1/10. Anything over 8%, you'll get to the nearest 0.5%. So it'll be 8, 8.5, 9, 9.5.
All right, so there you can see Weber State University filmed that video, and it's a pretty good one that shows you how that's done.
After completing the...
All right, so now we have gone through the initial tests, and we're going to talk about cores that have to be taken and strength tests. Determining how many cores you're going to need your third party to collect has to be done before pour day. So make sure you've talked to your site team, your PM, your soup, and you understand how many samples you need them to pull. If you're wanting to do an early break, you're going to need to tell them so they collect additional samples for that purpose. If you just do the base number of samples and you tell them to do an early break and something happens and it doesn't meet, then you're not going to have enough samples if you have to take it at the additional break timing. So please make sure that they're collecting enough samples. I already said that, don't collect enough. You're going to be in a position that you don't want to be in. Check your spec to see if field curing or a field box is needed on site. I would say 50% of the time they need a field box and they need to field cure. If that is the way your spec is written, then you have to make sure that they bring that field box and they have it set before pour day and that they don't take off with your samples. You don't want your samples right in the back of the truck back to their lab when it's supposed to be curing in your field box. So check that beforehand. And only because I've screwed it up. So I know in all these trainings, we're always saying, do this, do that, don't do this, don't do that. And it's only because we want you to learn from mistakes that either we've made or we have seen people make. Okay, moving on. Field cure tests. In field cure tests, the concrete cylinders are cured on site, providing a more accurate representation of the concrete's in-place strength. These tests are performed by placing the specimens next to the concrete slab on the site, adhering to standard curing methods specified in ASTM C31. Field cure tests assess the concrete's readiness for essential operations such as formwork, removal, tension, road openings. To me, with my background, I'm always a proponent for field cure tests. All that really means is they got a box and they put their cure box like right outside of your trailer, right by the steps, someplace where it's not going to get disturbed. To me, it just makes sense that you would want the samples cured just like the slabs curing, right? But a lot of times they're just standard cure tests. And for standard cure tests require curing the concrete cylinders in a regulated environment, ensuring consistent results for comparison. These tests are conducted following the standard curing method specified in ASTM C31 with controlled temperatures, humidity conditions to prevent moisture loss, guaranteed accurate strength estimates. The primary purpose of standard cure tests is quality control and concrete acceptance, ensuring that the concrete meets necessary specifications and possesses significant strength. So no matter what, I'm going to hope that you're working with a really professional third party, and if they're field cure tests, they know the days they have to do the breaks. They come, they have it in their schedule to pick them up, take them to the lab, and break them on the day that you want. And or if they're taking them back to their lab for the standard cure tests, that they don't forget the breaks on the days that you want them. If you're working with brand new and you don't feel very comfy, you could always try to micromanage that with them. And if you're wanting 3 or 7 day breaks, talk to them. Hey, I break in today. Just want to check in. Make sure you have my email address to send me results, or however you want to try to make your micromanagement sound better. I've been really blessed. Through my career, I've worked with different third parties across the United States, and most of the time these boys and girls are very professional, and they've got their lab certs for a reason, because they know how to conduct these tests and they have got a system that works. So hopefully you don't have any problems with that. Okay, making and curing cylinders. So the cylinder size can be 4x8 or 6x12, meeting the requirements of ASTM C31. Molding, there is a certain way to mold the cylinders. Big surprise. Like by now, after watching all the rotting, all the tamping, and all the videos, like you didn't think they were going to have instructions for molding. But cylinders need to be filled in 2 lifts. 2 for the 4x8, 3 for the 6x12, and consolidated to avoid voids using method like rotting or hand consolidation. Initial curing, cylinders must be moved to their initial curing environments within 30 minutes after casting and kept in the mold for a period of 48 hours at a controlled temperature. So that is how they're going to do it. In that upper right hand corner, you're going to see a gentleman preparing the cylinders, and that's what it looks like. Standard curing. After initial curing, cylinders are typically removed from the molds and stored in a moist condition. Temperature controlled. Cylinders should be maintained at a specified temperature range during initial and standard curing. And then again, we talked through field curing. In some cases, they can be cured in the field, exposed to the same environment. You may need to remind your testing agency to come and pick up the cores for the breaks if field curing is required. I think we already went through that. ACI 318, Building Code for Structural Concrete. 3-day, 7-day tests can be used to monitor early strength gain, especially when high early strength concrete is used. 7-day break is not a requirement for acceptance, but can be very helpful in assessing strength development for the concrete's 28-day strength test. More and more I'm seeing everybody, we're very anxious, right? If you're pouring a slab especially, you want to get on that slab and they want to build, they want to go. So if they can reach, typically the rule of thumb is 70% of the strength at an early break. Most end users will let you go. So a 3 or a 7-day break is pretty important when your schedule dictates, which in today's day and age means almost always. And that's why we do it, right? It lets everybody get on those the concrete faster. ACI standards generally use the 28-day compressive strength of concrete cylinders as the primary basis for acceptance. So you are going to keep having those cylinders broke until you meet that strength. If a concrete cylinder test at 28 days does not meet the required compressive strength, waiting for a later age, i.e. 56 days to test the concrete is also an option, as strength gains can continue beyond the 28 days. I've actually had to do this many times, actually, unfortunately, especially if they've added water on site. But that's another conversation, which I know if you've watched our concrete pour day module, you understand how I feel about water. But I've had this done. So again, the importance of making sure enough cylinders are pulled in case you have to hold one and break it at 56. All right, so that's really going to be the conclusion for today. We've walked through the different tests, shown you some videos so you could actually see what it's supposed to look like. Now, when your third party gets to site, hopefully you're not feeling like you have no idea why they are sticking that rod in there so many times. I remember the first few times I would just go out there and BS with the testing agency, and never in a million years did I have the ability to tell them whether they were doing it right until I went through the ACI myself. And again, I really, really, really highly suggest, if you're going to be in quality control for any length of time, that you go and get your cert and you go through it. If you've not looked into ACI tests near you, please do. Or ask your third-party testing agency if they'll even do a lab tour or a demo in their lab. I've been really blessed. Most third parties would love to show you their lab. They'd love to give you guys a tour. So ask them. Usually they do it for nothing, or maybe sandwiches or lunch brought in. I mean, it's a really good thing for your whole team. Be sure to grab recent copies of the ACI manual. I've put the link here. So grab the manual, look up tests in your area, talk to your testing agency. Again, it's a partnership, and the more educated you are as a QC manager, the easier their job is. And that's why usually they are extremely open to doing demos and tours of their lab. So I really hope this has helped. Typically we only teach, how to make pour day go smooth, which is more just QC manager tips and tricks. But lately we've seen a lot of newer QC managers being thrown on the site and having no idea what they're looking at. So hopefully this gives you guys a good introduction into the concrete tests and how they should be doing and how they should be ran. Hope you guys have a great day, and thank you for joining me.